Good morning, geometry. We are going to be covering section 1.3, midpoint and distance formulas. When we get into class, I will show you the programs. We have distance formula and we also have the midpoint formulas in the graphing calculators. So I'll show you how that works. Alright, so first of all, since we'll be doing the midpoint formula and the distance formula, we have to practice some of our algebra here. Here we go. Find a point between -3, 5 and, whoops, so much for that typo, 7, 5. Well, I conveniently have this little graph here. -3, 5 go over -3 up 5, there's point A. 7, 5 go over 7 up 5, there's point B. Now if you'll count the distance, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Halfway between is this point, which is 2, 5. Of course, you could just add up the two x's, -3 plus 7 over 2, and add the two y's, 5 plus 5 over 2 would get our results. If you recall, this is our formula for midpoint. Find the average of -11 and 5. We have two numbers here to find the average. It looks like there's a little glare there. Add them up. -11 plus 5 divided by 2 is going to equal -6 divided by 2, which is equal to -3. How about this one? Solve both equations. Solve this equation, solve for x. We're going to multiply both sides by 2. These twos cancel. You're going to have x plus 7 is equal to 10. Subtract 7 on both sides. X is equal to 3. Now, this next one, find square root of 30 to the nearest hundredth, and also in simplest form. Okay, well, square root of 30 is between square root of 36 and square root of 25. The square root of 25 is 5. Square root of 36 is 6. So it's going to be between 5 and 6. So it's almost exactly between. But if you look at your calculator, square root of 30, enter, is 5.477. You want to the nearest hundredth, 5.48. Now, simplest form is, can we break this down? Can I divide a perfect square out of it? Your perfect squares are square root of 4, square root of 9, square root of 25, etc. But nothing actually divides out of that. So simplest form is square root of 30. It'll come in handy for this next problem. Square root of 5 plus square root of 20. Well, we are going to do this one in simplest form first. So square root of 5, I'm just going to write it as 1 square root of 5 plus square root of 20 is the same as square root of 4 times square root of 5. 4 times 5 is 20. Square root of 4 breaks down to 2, so I have 1 square root of 5 plus 2 square root of 5. That answer is 3 square root of 5. This is the simplest form. Now, if I want to find that decimal value, press 3, then the square root, can you see that? 3, then the square root of 5, enter. You get 6.71 to the nearest hundredth. But otherwise, you can just type it in as square root of 5 plus square root of 20. Same answer. Alright, so here we go. Midpoint. Let me put my notes in front of me just in case I mess something up. Okay, with midpoint, that's exactly the middle. So there's a reason why we were doing midpoint formula before, because we want to find those middle points. And you are familiar with this formula, but I just want you to keep in mind, M is the midpoint of AB. Okay, so M is the middle. And the important part is AM, so this segment is congruent to this one. Notice the congruent symbol. But once I assign numbers, like if this is 5, that's 5, you're going to eliminate the line on the top, the segment type line, and then put equals. So congruent segments have equal measures. It's really important. All right, so using this diagram from the definition of the midpoint, so we know that this is the midpoint. AM is 15, so that means no, BM is 15. And I know that the segments are congruent, the measures are equal, so AB is equal to 30. And we'll just put units there. I don't know exactly how much. All right, same figure. So much for that straight line. Let AM equal x plus 12, and let MB equal 8x minus 2. Well, these things are equal, so let's set them equal to each other. 8x minus 2 is equal to x plus 12. I'm going to subtract 1x on both sides. 7x minus 2 is equal to 12. Add 2 to both sides. 7x is equal to 14. X is equal to 2. But now we need to find the whole length of AB. Well, if I substitute 2 in right here, this is going to be 14. This will be 14. 14 plus 14 equals 28. All right, next page. Okay, so this is a construction. We are actually going to do this in class. JD, I will do this with you as soon as you're done with this video, because I need to save up some time. Okay, the next part, segment bisector. Well, a segment bisector is a point, a ray, a line segment, or a plane that intersects a segment at its midpoint. So that means O is the midpoint of AB. I'm going to write that down. Oop. You just want to capitalize your points. All right, so that means this is going to be the same as this. This is a line, so I don't know if that's going on forever, so you can't really cut that line in half. Keep in mind, L is a segment bisector of AB, so the congruents are, the segments are congruent, and their measures are equal. So here we go. Use the same diagram, and AO is equal to 2 2/3. 2 2/3. So that means this is also 2 2/3. Well, I want to add it up. So well, we already found OB. So AB is going to equal to, I'm going to change this to improper, or improper fractions. 3 times 2 is 6 plus 2. Well, let's see here. Something is not right. I've got the wrong information in my paper. 3 times 2 is 6. Oh, that's an 8. That's why. Now I know. I'm looking at my notes and I'm like, I'm not getting the same thing. 8 times 2 is 16 plus 2 is 18. Oh, that's supposed to be a 3. I am a mess. Okay, so 19 over 8 and plus 19 over 8. 19 plus 19 is 38. And I'm actually okay with this answer, but we should always reduce it. That turns out to be 4 6/8, which is equal to 4 3/4. How about this one? Find the average of 17 and 39. Remember, if you're going to be adding up or finding the average, add them up. Divide by 2. You get 56 over 2, which is equal to 28. All right, the next part, midpoint. So we want to highlight this. This is our formula, midpoint of AB. And you're going to notice there's always lots of abbreviations in geometry. Add up your 2 x's, divide by 2. Add up your 2 y's, divide by 2. So there's your formula. Basically, you're finding the average x, comma, the average y. All right, so far so good. Next page. Hopefully we're going to get this done in time. Alrighty. So given the endpoints, -3, 2, and 9, 2 for J and K, find the coordinates of the midpoint. Draw and label. Okay, so the midpoint, can you see that? We're going to take the 2 x's, -3 and 9, divide by 2, and then the 2 y's, 2 plus 2 divided by 2. -3 and 9 is 6. 6 divided by 2 is 3. 2 and 2 is 4. Divided by 2 is 2. Here's our midpoint. So if you wanted to, you can actually put that on graph paper. Count over 1, 2, 3. Go up 2. Count over 9. Go up 2. The midpoint will be right in the middle. Okay. So graph paper is always handy. If you're taking the ACT and you forget what you're doing, make a makeshift graph. All right. The midpoint and one endpoint. So this one's kind of tricky. M is the midpoint of AB. M is negative 4, 5. A is 2, negative 1. They need to find this. Okay, so keep in mind how to find the midpoint. You add up your two x's. So I'm going to say x1 plus 2. That's we're going to call this x1, y1, divided by 2. That has to equal negative 4. So now you know why this was in the warm-up, huh? Multiply both sides by 2. I have x1 plus 2 is equal to negative 8. And then if I subtract 2 on both sides, x1 is equal to negative 10. Now let's do the same for the y point. y1 plus a negative 1 over 2 is equal to 5. Multiply both sides by 2. y1 plus a negative 1 is equal to 10. And then add 1 to both sides. y1 is equal to 11. So this endpoint is negative 10, 11. Again, we will be doing this construction in class, so don't fret. Distance formula. Now if you recall, distance formula, distance is equal to the change of x, square it, plus the change of y, and square it. This is actually Pythagorean theorem. Remember Pythagorean theorem? A squared plus b squared is equal to c squared. So earlier when I showed you this, when you see these absolute value signs, you're finding the distance. So the distance between x1 and x2, and the distance between y1 and y2. That's basically this part. And if I square this, and square this, and square this, you have your Pythagorean theorem. You want d by itself, so take the square root. Alright, so I'm going to highlight this because we definitely want to know this formula. And again, the ACT will let you use that formula on the calculator, and I do encourage it. So moving on. We're about 15 minutes here, so I want to keep going. We might do the challenge problems later. We'll see. Okay, label the points on the axis below. So 2, 5, go over 1, 2, up 1, 2, 3, 4, 5. Okay, there's our A. And then 4, negative 1. 1, 2, 3, 4, negative 1. And there's our B. So we want to find this distance. So the distance of AB is equal to, take the difference of your x's, so 4 and 2, square it, take the difference of your y's, negative 1 minus 5, and square it. 4 minus 2 is 2. Negative 1 minus 5 is a negative 6. 4 plus 36 is equal to the square root of 40. Of course, we have to have this in simplest form. That's the same as square root of 4 times square root of 10, which is 2 square root of 10. So there's your exact answer. This is between square root of 36 and square root of 49, so this is about 6 point something. Let me know later. Okay, now do the same problem, but we're going to use Pythagorean theorem. So we have 2, 5, and then we have 4, negative 1. So we're going to use Pythagorean theorem. This distance is 2. This distance is 6. And we'll call this C. That makes a right angle. 6 squared plus 2 squared is equal to c squared. And I need c by itself, so take the square root. Square root of 6 squared is 36. sorry, 6 squared is 36, 2 squared is 4, you get square root of 40, which you know is 2 square root of 10. So I want you to keep in mind, same things. The challenge problems we will also do in class, because I see that this video is getting a little bit long. We'll take care of all that. Here's your homework. We'll do that in class, and there's your standard. Everyone have a nice afternoon. Thank you.